by an internationally famous open source guru. For those who don't know him, please give a warm welcome to Chris Dibona. Thank you.
So I think it's a measure of a good event that whenever I stand up at these G events, like the ones we did in Egypt and now here in Jordan, I kind of want to go to the other talk, personally, but I can't because I'm speaking. But you have a good chance after this one to go to two other really great talks too. So we'll talk about that in a bit. So who am I? I look after open source for Google, which is sort of an unusual job in a company in that I don't look after the code so much that we, Google, have written, but so much the code that all of you and the world has written that we use. And then I try to make sure that that code is looked after properly and that we have the right relationship with developers like yourself. So let's get started. Very simple agenda. I just really don't like agendas. So we're just gonna skip that. And then we'll have some time for questions at the end, though, if you'd like. And I'll be available outside near the demo pods if you want to talk further. So first, let's talk about open source. How many of you are familiar with open source? Just raise your hand. That's about typical. Yeah, that's good. That's good. Although more of you understand open source than folks in Egypt did, so that's interesting. Open source is a lot of things, but these are sort of the things you really need to understand about it. It's free of cost, meaning there's no money that needs to change hands to use it. It's software that you're able to use and ship to your customers, your friends, your employees, consultants, whatever. And it's modifiable by you. So you can't take a piece of open source software and say, you can't do this with this software. Anything you want to do with it, you can. You can change it, you can modify it, you can. If it's really only designed to do one thing and you change it to do something else, that's okay. And that can't be stopped. And therefore, it also has source code available. So you have to be able to get at that code so you can do those modifications, so you can exercise those freedoms with that software. And then it's tautologically licensed under an open source license. And licenses are a pretty complex topic, but I'm not going to get into them too deeply. If you like open source license discussions, find me outside, ask me later. But I usually don't want to bore people too much with that. But they come into two broad categories. The kinds of open source licenses that ask you to share your code as well, and the kind that all they ask for is credit. So for instance, when Google releases the code for something like Android or Chrome, we released under the latter. We really only want to know that you're using it, not how you're using it, not what changes you're made to it. We hope that you'll want to work with us at that level, but you're not required to by the license, because we're trying to get our code out there and trying to get it used. And it's about half and half for all the open source code that's out there. About half of it is under these. You have to share 2 licenses versus the, just let people know you're using it. That's cool. So that's open source. Now, this would all be just an academic exercise if it wasn't for the fact that there is so much functionality out there and it's so useful. We did a study of all the code on the internet. You know, Google crawls the internet all the time. We also crawl all the source code on the internet. And what we found was about 31 million, and this is about a year old, mind you, so it's probably more than that now, about 31 million unique files that came under an open source license. And there's the breakdown of licenses, if you care. But what this means is there's about 2 billion lines of code that have been written, that have been released under open source licenses. This is the equivalent of about 10,000 developers working for 10 years to create high-quality software. So it's a staggering source of productivity. It's a staggering, I hesitate to call it a natural resource, but it's a staggering resource for anyone to be able to take advantage of. And it's pretty remarkable, the code that's out there. I'm not going to say that you can just pick up this code and run with it, but you basically can. You can use it in your software, you can use it to advance your software, and it's pretty remarkable in that it's out there for you to use. This chart basically reinforces that about half of it is under extremely liberal licenses, and another half is under the more share-alike style license. So in America, and I'm sure here too, we have a tendency of looking at things that are free, that are given to us without cost, and being somewhat suspicious of it. And there's a saying, there's no such thing as a free lunch, right? Except for at conferences. But but in return you have to watch the video about Chrome being fast. No. So we decided instead of postulating and making up things about why people do open source, we decided just to ask developers why they did it, what made them take something that we all know to be quite valuable and just give it away. And it was actually a really interesting and, in my mind, very encouraging result. Up until we did this study, most people were like, well, you know, you open source people, you really only like it because you hate Microsoft. And it turns out only about a tenth of us were motivated by hate. So that was really cool, because I never got into this business because I hated somebody or hated Microsoft. I love computers. And most of us do it because, you know, we're curious about how computers work and how software is developed and what we can do with software. And that's pretty amazing. And most importantly, and this is actually what got me into open source software, was I wanted my job to go more smoothly. I really didn't like being woken up at 3 in the morning with my pager going off. And it was very frustrating. And then finally, I'd like you to notice that a lot of people see computer science as that, as science. And so it's something that we share and we try to advance together. And so this was a great study. I'm really happy with the results. And again, you know, we're not just haters of Microsoft or whomever. So that's awesome. Unless you do, in which case, more power to you, but, you know. So what about Google? How do we use open source? This is Google. You know, whenever you're using Google, you're using, no, well, so this was Google about 12 years ago. Our founders, when they decided to do their research on link propagation on the web, they needed computational capacity, and they didn't really care how they got it. So what they did is they walked up and down the halls of their Stanford labs, and they found any computer that wasn't plugged in, and they took it, and they plugged it in, they installed their software on it, and they ran it. And in a lot of ways, this is the last time you saw a heterogeneous network at Google. It was probably also the last time you saw Legos as a hard drive enclosure at Google. But yeah, so you have some IBM there, some Sun there, you know. But there's also a lot of Linux in there and some BSD in there. BSD is another operating system some of you may be familiar with. And this sort of kicks off in what we really care about is computational capacity at Google. It's really, really important to us. The algorithms you hear so much about from Google, the tools that you use every day, they happen because we have a lot of CPUs and we have a lot of hard drives and we need a lot of them, and we have since day one. And so when we were faced with the demands of growing the service and we finally had a little bit of money to spend, we could have gone one of two ways. We could have gone and spent, you know, a ton of money on, and I'm using quotes here, fault-tolerant computers. We could have spent money on RAID arrays, extremely expensive server-class hard drives and CPUs. But instead, we sort of piggybacked on all of you. While all of you were out there buying hardware for your desktops and for your laptops even, we were right alongside you, buying the same hardware, the same hard drives, the same CPUs, the same kind of memory even. It was only until about 2005 that we started using ECC memory in any sort of quantity. And the reason for this was that for the cost of a machine about yay tall, with 4 to 8 CPUs, we could fill up 2 racks with this junk, okay? Now this junk, as I call it, is really fast. So for every 2U, so every space about yay big, we could fit 4 CPUs, a ton of memory, 8 hard drives, 2 power supplies to power it all, and 4 network cards. So no cases, and we could run a lot of software very, very quickly in something this size. How many of you watch this and just get a little shaky? What's wrong with this? Anyone? What about the heat? Well, it's funny you should mention heat. So if you look in the background there in this little hole, you'll see fans, but even that wasn't enough. We got a bad shipment of hard drives once, and it had too much, I think, indium in the solder they used. And so as the heat rose, as heat will do, I don't need to tell people who live close to a desert how heat works, but as the heat rose, the hard drive solder got softer and softer and softer until the hard drives in the very topmost machine melted and onto the machines below them. So that was bad, right? But that was just a hard drive solder failure. It wasn't really a failure of design. But basically, we would pump a lot of air past this. We even went so far as to orient the memory sticks in later versions of this so that it would permit airflow. Another problem we had, any other problems? Anyone else want to volunteer? You got your hand raised. Fire hazard. Well, yeah, it's very much so. Yeah. Yeah. Dust is not as much of a problem because this is the problem with cases. Cases tend to create zones where dust can gather. Something like this, it just blows dust all over the room, you know? So that's kind of helpful, yeah. The networking cables, that's actually a good eye. So what would happen was, if one of these machines would fail, eventually we'd get around to pulling it out. And as you pull it out, these cables would catch on the board and would snap the hardware right off. So that's bad. You don't want to snap your hardware off. You want to take it out, right? But we got a little better with things over time. But this was great because it allowed us to do a lot of processing very, very cheaply. And then we just ran Linux on top of this. And this continued. You can look over here at our advanced cooling system in the bottom right-hand corner here. So again, we're still using the same hard drives that you were buying, the same CPUs, all of that. And we were running Linux on top of it and deriving our reliability from Linux, from our software. And a very small amount of sort of routers that were probably very expensive to help us with the load balancing. But yeah, it was how we did things for a very long time. And we got better and better at it until we started building our own machines and our own data centers. But at the same time, the costly components were the same ones and are still the same ones that you buy. And it served us really quite well. And we were able to do this because of the open source software running on top of it. So when we use open source, what we're doing, and what you're seeing whenever you use Google, is you're all using Linux all the time whenever you use Google. And then on top of that is the software we've written using open source tools like GCC and Python and others, combined with open source libraries from folks like Apache and others, and then combined with our software. So it's very, very simple. And because of that, we're able to sort of take this enormous productivity gain of open source and combine it with our software. And that's Google. But the question then becomes, but why? You know, Google is pretty big now. We have probably enough money that we kind of don't need to do this stuff if we don't want to. And you know, it's not rocket science to say we don't want to throw away, you know, functionality. But why do we really use open source? Why have we used it from the very beginning? And I'm going to tell you a story. A friend of mine told me about his time at French Telecom. So in 2004, I believe it was, or 2005, France Telecom had decided they wanted to ship push-to-talk on their network. That's like walkie-talkies, you know, boop, boop, like that. And so people would talk. And so they spent about $2 billion US upgrading their entire carrier infrastructure. It's very expensive to do this across the whole country. So they spent this money and they had planned on bringing out a phone running Windows Mobile, although this is, again, not an anti-Microsoft talk, but you know, it's a control your software destiny talk, and they come up. And as they were getting closer and closer to release, they were about 3 months out. They had sourced a nice phone from a Taiwanese vendor. And as they were getting closer, they found that every fifth, it was failing. And sometimes the machine would reboot. Sometimes it would just fail. Sometimes that call would fail. It was a bit unpredictable. And so they went to their engineers and they said, hey, this is a real problem. What can we do about this? And they looked into the problem and they said, well, it looks like this particular shared object is bad. Let's go talk to the vendor. So they went and talked to the vendor. They said, hey, this is a problem. And Microsoft said, well, yes, we know about that. And they're like, oh, magnifique. That's great. Fantastique. My French, that's all my French, by the way. Well, almost all. And, and they said, you know, we know about this. And they said, well, can we get a fix so we can ship our phone? And they said, well, you can, but it's in the next version of the operating system, so you need to adopt that. I'm like, okay, that's fine. When is that coming out? And they said, 18 months. 18 months? Sacre bleu, we can't do that. And they said, well, can we get it earlier? And they said, I'm sorry, but we can't. And so they ended up not being able to ship that phone. They changed the button, the cool button, into like a mute button or a camera button. And they had a Symbian phone that came out about 2 or 3 months later. But it was lost time and lost money and a lot of trouble. And the reason that Microsoft didn't allow them to ship their phone with the new version of the operating system is to cut a special version of Windows Mobile was going to be very costly to them. They would have to support it They'd have to have a special version of it. They'd have to track changes into that version. Those of you who have been in commercial software development know that these things cost money. And so you do that very simple equation of what is it going to make us versus what is it going to cost us. And at the time, France Telecom was only about 4% of Windows Mobile revenue. So they said, okay, it's not worth it. This one phone, this one fix is not worth the trouble. And I'm not saying they were wrong. They did what was right for Microsoft. And France Telecom was kind of left out in the cold, but that's the price of picking someone else's software. So the nice thing is, at the same time, Google had a need to allow user space programs to use ports under 1,000, which is a little unusual in Unix. So if we had a commercial vendor at the time, we would have to gone to them and said, we need this from you. They would have had to have figured out what to charge us, or if they were going to do it at all. And then they would have charged us by the CPU, by the thread, by the memory stick, by the whatever they charged by. And it would have taken a long time. As it was, since we use Linux, we made the change and shipped it out in about a week. And it didn't take very long. It's actually a very simple change. So, that really appeals to us. We like not having to go through an outside authority to develop our software. That sort of frictionless being is fantastic. And it's one of the reasons why people use open source at all. There's no one telling them they can't do something. There's no license that says, you can use it, but not in search. You can use it, but not in Jordan. Before open source was codified as having field of use requirements, you would commonly see people say, this software can be used by everyone but people in Israel, but people in Egypt, but people doing nuclear weapons, but the military. And all these motivations that really had no place inside software, frankly. So open source stopped that and made it possible for us to share information as computer scientists. And that was pretty fantastic. And that appealed to Google. And it appealed to engineers. So I could stop there and say, that's how we use open source, rah, rah. But I'd like to think we go a bit further in how we help out open source. And let's help out all of you. We could have shipped Android without sharing the code. Instead, we chose to share the code with anybody who wants it. And yes, that was good for the platform, and it moved things forward quite quickly. But we probably could have done that without it. So why did we do it? And I'll get to this in a second. The funny thing about open source is you can just use it, and it'll serve you really well. But if you understand where it's going and perhaps influence what direction it's going, it's really good for the software you write. So you understand where your business is going year on year. And so we try to do a couple of things to ensure that open source remains healthy and vital for Google, as well as for everyone else. So the first thing we do is we provide infrastructure in the form of project hosting. We provide version control, bug tracking wikis. And we have about, this is a little older number, we have actually about 340,000 projects registered on the site. It's pretty big, and it's pretty exciting, so it's worth checking out. You could be creating a code.google.com project today and have it done in about a minute. It takes no time at all to create. You could be committing code before the end of the day as an open source developer. But the real currency, in my mind, of open source participation is the source code. So starting about 6.5 years ago, we did a concerted effort to make it very, very easy to release open source software. And since then, we've released about 20 million lines of code into thousands of projects, as well as projects that we ourselves have released. To date, we've released about 900 Google projects, Google-specific projects, on top of all the projects that we tend to patch into. And then you have what I consider major projects. Things like Chromium, which is the open source componentry of Google Chrome, which we started when we saw that the world of web browsers was stagnating a bit. It was fairly slow. And by slow, I mean speed-wise. I don't know if you saw the Google video of the potatoes being thrown through the graters. It's a fun way of presenting that. But at the time when we started Google Chrome, the other browsers weren't as interested in speed as we were. And we knew that for people to continue to use the web as, in a lot of ways, a desktop replacement and to spend more time on the web, they would have to feel that they were in a world that was as responsive as a desktop, as safe as a desktop was supposed to be, and as clever. So that was sort of the goal of Chrome, and we think we've done a good job of that. Now, we could have just stopped there and just shipped it, right, and had it stay closed. But instead, we chose to release it under a BSD license, which means that Microsoft, Opera, Firefox, Safari can all consume code from Chrome if they like it. If they agree with us that maybe speed matters, and they find the code that we write interesting, they can just use that code. And that's an explicit goal of the project, that they're able to do that. And we spent a lot of time releasing code from Google Chrome into WebKit, which is combined directly into Safari and a variety of other browsers. So, and that serves our needs on the web, too. And then Android, if you look back about 6 years ago, the state of mobile phones was fairly interesting. It was largely all Nokia. I'd imagine most of you have Nokia phones. They have pretty terrific Gigabit support. That sounds like, yes, I love it. But at the time, Nokia was about 94% of the web, of the mobile market in smartphones. And why that's an important number is, at the time also, Microsoft Windows held a 94, 95% monopoly on the desktop. Now that hasn't changed so much, it's worth pointing out. But in smartphones it has. It's changed dramatically. Now we have a world that is probably about 60% Nokia, and then a fair amount of iPhone, and a lot of Android too. So that's actually a really good situation for the market to be in. It's very good for you as a consumer. You have multiple competing proprietary and open source cell phone operating systems who are all trying to please you the most. That's a great outcome, because I firmly believe, and the company believes, that what you desire most are free internet browsing experiences. And by free, I mean freely available. Even just 5 years ago, I could point at half a dozen phones who would let you go to a couple of websites. Not all of them, but just the ones that had paid those vendors or those carriers. And it was fairly odd and strange. We didn't want the mobile space to end up looking like a walled garden like that. So that's why we worked on Android. Now we're actually shipping, again, this number changed on Monday, so forgive my slide being out of date. We're actually activating 300,000 devices a day now on Android. So it's a pretty terrific environment to develop for. And then another thing we noticed was that, and these are decisions in a lot of ways that go back 5, 6 years, even before I started at Google. Video is always a really interesting space online. If you look at the sort of dominant codecs in video, which are H.264 and MPEG and the rest, they were not made with streaming in mind. And so you have to bolt on these strange sort of buffering structures around them to get them to work. And the ones that were network friendly were actually not very high quality. So they would end up using a lot of network bandwidth to achieve that network friendliness. And also, they were very, very costly. Whenever you buy a phone, there's a small portion of your bill of materials that you're not seeing, but are raising the cost of your phone by 50 cents to $1 that goes off to the cartels that look after these codecs. And we felt that that's an untenable situation, and one that actually holds back innovation on the web. So we purchased a company called On Technologies that we were familiar with, who are working on a very high-quality codec, and we released their work for free into open source and implemented it in places like Chrome and YouTube. And we didn't just release it for free from a copyright perspective, but also from a patent perspective. So you knew that we were not going to come and tap you on the shoulder later and ask for $1 from everyone who might use Android or Chrome or the rest. And that's pretty fantastic. And then the other problem we saw in open source was that they were kind of aging out. I would go to these conferences and I'd be seeing a lot of the same people. A lot of the same folks year after year. And that was getting pretty tiring. I mean, I like my friends, don't get me wrong, but for open source to continue to propagate and to be healthy, it needs new members of that community. And so we started the Summer of Code back in 2005. And what that does, and I understand there's a fair number of students here today, is it introduces university-level students to open source software development. We pair up the students with the open source projects and the mentors therein, and they're able to work on real computer science problems inside projects that see real user need. One of the things about open source about computer science education is that it focuses logically on the theoretical and procedural and the tautological. It's about teaching you how to program, teaching you how algorithms work, teaching you the basics of computer science. Open source is really great because it teaches you what happens when that kind of learning and that kind of knowledge meets real user demands. And then we also pay the students for their time over the summer. It's about $5,000 if they're successful. It is a merit-based program. We fail about a fifth of the students every summer. who don't manage to do what they need to do in the project. The last time we saw a Jordanian in the project was 2007, which is disappointing. So if you know students, we would really like you to find someone in Jordan who could take part in this program, because it's a shame that there aren't more of you here. In Egypt, I got to see about 5 or 6 of the folks who showed up who had taken part in the Summer of Code over the years. So there you go. We also have a high school version of this, a high school, meaning under 18, pre-university, so which is much smaller tasks, and in some ways a little easier and a little more diverse in terms of non-coding projects. So if you have a child who's under 18 but above 13, if you have friends who are in university, let them know about the program. We would love to pay them to learn how to do open source. Because what we found was that after we were done paying them, they kind of stuck around. And it made open source better. And frankly, the state of Arabic support in open source could be a lot better. You know, it could be a lot more friendly to the region. So in some ways, I'm counting on all of you to do that. So yes, I can take questions now for about 4 minutes, 1 minute, and I have mugs, which I can just throw into the crowd, right? Is that what you should do? You know? Don't throw them? Okay, there's a question. Okay. Can you get a mic to her? We have someone coming in to you, right there.
This program about open source that we can participate in as students, how can we apply to it? And
okay, it's actually quite easy and hard at the same time. So go to the code.google.com or just search on Google for Summer of Code. And we partner up with 150 different open source projects, all kinds, games, kernels, compilers, content management systems, whichever you prefer, and get to know them. Go look at their bug trackers, go look at their ideas lists, and then get to know them. Get on their mailing lists, that sort of thing. So that when you do apply, they know who you are, and they know that you're capable of doing the work. And then when you apply, what you do is you either select one of the ideas that they've presented on their websites, or you pick one that you yourself have come up with, and you suggest to them that you're the one to do that. And you say why you think you're the right person to do it, and the kinds of things you've done before, you know, sort of basic CV stuff too, and how long you think it'll take to do it, and how you'll approach the problem. And in my experience, if they already know who you are from their chat channels and from their mailing lists, you're very likely to get selected. So that's what I would do if I were you. So Mike for her?
Thank you.
Mug for her? Is that it, really? I'll be outside. So
right,
fine.
exactly. Thank you, Chris.